To support our discussions with the world's leading thinkers, please see the video description or visit eism.eu/support. Thank you.
Hello and welcome to A Theory of Everything. Today we have the pleasure of talking to Dr. Christopher Ferrie, an Associate Professor of Physics and Quantum Information at the University of Technology in Sydney, Australia. As always, I'm going to take a couple of minutes to talk about what I think are the most important takeaways from the exchange. If you'd like to skip this introduction, see the timestamp in the video description. Professor Ferrie obtained his PhD in Applied Mathematics from the Institute for Quantum Computing at the University of Waterloo in Canada. In addition to leading a research team at the University of Technology, Ferrie is a popular science communicator who's had a great deal of success with more than 50 science books for children, such as Quantum Physics for Babies. If you have small children, you should take a look at these. They are really good. Today, we're going to talk about his most recent book, Quantum BS: How to Ruin Your Life with Advice from Quantum Physics. Let me start by saying, first of all, that this book is the funniest book you're likely to read about quantum physics. I highly recommend it, especially if you're not put off by very funny and very well-placed F-bombs. On the other hand, I would not have invited Ferrie to the channel if I didn't think his book also has an important message, and it certainly has that as well. My conclusion after reading the book and talking to Ferrie is that there are two different kinds of quantum BS. The first, as Ferrie points out, is the kind spouted off by people who are not trained in quantum physics. And the second kind comes from people who are trained in quantum physics, but then step over their bounds to make nonsensical declarations. The second kind of BS is far more dangerous than the first, precisely because it comes from some of the planet's most intelligent and highly trained scientists. One way to measure this second kind of BS, according to me, is to ask what anybody's interpretation of quantum mechanics has to say concretely about the fact that the planet is currently full of nuclear weapons. It stands to reason that when nature allows for different but equivalent interpretations of reality, we should give preference to those interpretations that can lower the risk of human extinction. You don't need a PhD in physics to understand that this is common sense. So what does Professor Ferrie think about this proposal? I'll let you hear it from him directly. In the end, from my perspective, the most important message of Ferrie's book is that BS is often in the eye of the beholder. Nobody ever thinks their own ideas are nonsense. It's always other people who are peddling the nonsense. This is worth reflecting on, especially if you're trying to convince people that free will is an illusion, or that life has no purpose, or that there are an infinite number of other worlds with copies of you in them. When you hear these things, even from otherwise distinguished scientists, don't be afraid to ask the person to spell out what their ideas have to say concretely about the fact that the planet is full of nuclear weapons. This request for thinkers to connect their ideas to what matters most to all of us, in my opinion, is a very handy and effective BS detector. And that's the main takeaway from today's exchange. Stay away from the quantum nonsense of people like Deepak Chopra, but don't be so quick to cling to the baloney of people with PhDs in physics either. Sort through all of the nonsense through the normal empirical methods, but then ask the Deepak Chopras and the Sean Carrolls of the world to connect their ideas and their speculations to long-term human survival and to the biggest open questions in political and social science. That is the challenge and the question of all questions. If you disagree with me and with past guests like Michael Freedman, the Fields Medalist, or Carl Friston, and you think that human survival is not a valid domain for physics, please let me know. I'd love to have you on as a guest. On that note, I'll close this intro. Thanks again for your time and interest. leave links to Professor Ferrie's book, which I hope you'll read and think deeply about, as well as several other relevant links in the video description. So here, alas, is the very funny, but very serious and also very generous Christopher Ferrie. Professor Ferrie, welcome to the channel and thanks for taking the time to talk.
Hey, thanks for having me.
So you've written a really, really funny book with lots of F-bombs and lots of hilarious references to dried fecal matter on cat fur. But the book also has a really deep and important message about science in general and about the distinction between quantum horseshit and quantum bullshit. Before we get into the book itself, I'd like to ask about your sense of humor. Where's it come from? Were you funny even as a kid?
Yeah. When I graduated high school, I wasn't the I wasn't the quarterback or the homecoming king. I was actually voted the class clown, so it's I guess it shouldn't be that surprising.
I suppose. Well, the book is really, really funny. I enjoyed it the whole time. You get away with the F-bombs and the references to of course bullshit, and it just makes it so enjoyable. You have 4 children. Have your kids inherited your sense of humor? And did you get yours from your parents, for example?
Yeah, I think so. It's sort of a dry, sarcastic humor. I think I got it from my dad, and my kids will probably pick up some of that. I can certainly see a little bit of it in them now, and maybe I'll pay for it in the future.
Well, it's really funny. No, I think it's really, really good. And I think this your approach to humor and to life, and even to something as serious as quantum physics is I think refreshing and very nice. Well, prior to writing this most recent book on quantum bullshit, you've had lots of success with children's books. Can you tell us about that and how this new line of books, I suppose, fits into your overall vision as a writer and science communicator?
Sure. Well, that part of the story is quite easy. I wrote the kids' books when my children were quite young. So the books are for babies. So the most popular one is called Quantum Physics for Babies. And I don't have babies anymore. My kids are growing older. And so some of the books that I've been writing have kind of been growing with that audience. But as my kids enter into the teenage years and into early adulthood, the challenge for me is to still connect with them at a time in their life where it seems like reading is the last thing that they want to do. So there was that gap in my audience. I was connecting with children. I was connecting with parents, even grandparents, reading to their grandchildren. But that sort of young adult audience was one that I hadn't hit yet. And I thought, this sort of humorous kind of, it was written during the pandemic, so I think it also hit the zeitgeist of the time. I thought that would hit the mark with that particular audience.
Excellent. And your series of books with for children, if I am right, you have more than 50 of them so far.
Yeah,
right?
I've written about 60 books total.
Wow.
I have now a few adult nonfiction books, some picture books. There's an activity book about science experiments for a little bit older audiences, like 10 to 12-year-olds, and then most of the books are these ABCs of various topics in science, and the series that ends with for babies. So there's quantum physics for babies and blockchain for babies, and sort of as many complex and esoteric topics as I could find.
Amazing. How did you find this mission of yours? Did you expect it? Did you think it out carefully, or did it happen by accident?
Well, teaching for me is a selfish endeavor. So I just want to learn, and I find the best way to learn is to teach. So even just if I had no intention of actually publishing and printing and selling these books, I still would have written them, because the process of writing down and going through the motions as if you were going to teach it to someone else is valuable in understanding something yourself.
Very true. Very true. I think my experience is also similar to that. Interestingly, in your book, Quantum Bullshit, it's a very funny book, but in the process, it actually teaches some really interesting things, and you cover some interesting topics. Have you taken a similar approach? And no, in this regard, you weren't really learning, obviously, because you are already a physicist. But you do manage to cover some of the fundamentals in a very enlightening way. Can you tell us about this process? Because it's a gift. I think it's a gift. Not everybody, even if they try to, can write with this kind of clarity and also depth at the same time. Can you tell us about this process?
It's not, there's no formula, actually. So it's, I live a chaotic life, and it's all about sort of embracing the chaos. So a lot of the books that I write don't find a very obvious sort of genre, right? So this is the adult comedy, but it's also popular science, as you say. I think that I have explained quantum physics in some of the best ways that I personally have seen, and so it's somewhat a popular science book. It's somewhat of a comedy book. It's somewhat of a self-help book. It doesn't really fit into a category, and that's kind of how I've lived my life. I started my university degree as a mathematician, and then moved to a physics department, and now I'm a computer scientist in an engineering department, and maybe 5 years from now I'll be somewhere else. And bringing all of these different topics and experiences and areas of science and philosophy together into one thing is just something that I've been doing my whole life. So it seems somewhat natural for me, I suppose I would say. Yeah.
Well, very cool. Very cool. I'd like to stress to listeners, and I suppose you agree, but for somebody who's completely confused by all of the talk about quantum physics and quantum computers and whatnot, this is a very handy, nice, enjoyable way to get a decent grasp of some of the basic concepts. I suppose you agree with that, but I just wanted to make that clear to listeners. That might serve as a good transition to some of your actual serious work as a scientist. Can you tell us about that, and what are some of your interests? What are you working on?
Well, I lead a research group at the University of Technology, Sydney. So there's a research center there called the Center for Quantum Software and Information. And we broadly, all of us together, study the theoretical aspects of quantum computing. So there are companies, there are research groups around the world trying to build the hardware, the physical stuff that may be able to compute with quantum information. But the question about what can it compute, and how do you verify that it did compute what you promised it would compute? These are questions that are for people like us, the theoreticians. So my research group is a sort of a broad research group, but mostly works in the verification and analysis and control of these quantum computers. Sometimes the hypothetical, looking into the future, but at other times, some of the stuff that we work on gets implemented in labs in Australia and around the world.
Fascinating. Well, can you tell us about some of your research or your findings, your conclusions about the direction or the current state of quantum computing and the various players that are involved, IBM and Microsoft, et cetera? What's your take on it? Is there a lot of bullshit, some bullshit, more horseshit? Can you tell us about that?
Yeah, well, so the distinction I make in the book between bullshit and horseshit is like, bullshit is intentional. It's used with the intention to deceive, whereas horseshit is just wrong, and maybe you've been misled and decided to repeat something that you heard. So in quantum computing, there's a little bit of both, but broadly, a lot of what you see in the media is bullshit, in the sense that it's overinflated, and there's a lot of hype surrounding quantum computing, what we're currently able to achieve with the technology, and the promise that it may have. So for me, it's quite easy. You know, I do research in this, and if a company has something that can solve my problems faster, then they'll bring it to me, and I'll evaluate it, and I'll use it if it works. And that's just not happening. But when I read media articles like everyone else, you know, apparently large multinational companies are paying these other multinational companies that are selling quantum computing solutions large sums of money to solve their problems, when to me, there's a lot of trade secrets involved, right? So you can't really evaluate it unless you go in and look at what's being done and what's been achieved. But it's highly, highly suspicious, the claims that are being made.
Interesting. Well, we're based in Barcelona and Madrid, and we're involved in several international European projects, some of them involving quantum physics and quantum computation. What, in your opinion, is the most promising potential at this point? I think we all agree that there's a lot of hope in the sector, a lot of hope for the technology, but it hasn't panned out as much as it's often portrayed in the media. Do you think there's a special promise in one particular line of research or work?
No, I think it's too early to tell which, say, platform will be the best, or let's say the first to scalability. It's too soon to tell. We measure sort of the information capacity of quantum computers with quantum bits, or qubits, as you may have heard. And to run an algorithm that we know will work and provide some big advantage over conventional technology, we need millions of these qubits. Whereas today, I should also mention that they have to be perfect as well. Whereas today we have hundreds, and they're terrible. So, you know, we're a long way off, though I think I'm optimistic that we'll get there eventually. It's just a matter of, you know, the steps along the way and how fast we can achieve them. But there are many, many steps between now and a million qubits.
Excellent. Well, we skipped over, I think, an important point, talking about quantum bullshit. And talking about quantum bullshit. And the book opens up referring to some of the quacks and whatnot that are selling questionable products and services on the internet, such as, solve your quantum psychology, et cetera, et cetera. Can you tell us a little bit about that aspect of the book? Do you think it's an important aspect of the book? And is one of your aims to get people to understand that this is pure quackery?
Yeah, so the book steps through sort of the major concepts in quantum physics, and then how each of them is misused. And where each is used and misused, really, it depends on the concept. So the concept of quantum energy is really often used in what's known as energy medicine. And you get things like everything from selling you a polished rock, right, which they might have a fancy name for, and say it's a crystal, and it's going to vibrate with your chakras or your energy field, or just using words from physics and quantum physics that have no meaning in the context in which they're being used. So I explain how quantum energy really works, and clearly why these devices are not using quantum energy. And in fact, they're probably not doing anything at all. But then you have concepts like quantum uncertainty, and that's used in other areas. So that's used in I have an example of art where there was an artist that claimed that they were exploring the concepts of quantum uncertainty through the, exploration of poetry using the medium of sheep. And so she had spray painted sheep and let them, graze in the manger, and then would take photos and then look at the words that she had spray painted on them and in what order. Of course, this has nothing to do with quantum physics, right? And that seems pretty innocuous, but it's incredibly misleading to think that our everyday world and the kind of randomness or uncertainty that we experience has anything to do with quantum physics. And telling people that can lead them to believe other things, leading back to, say, energy medicine, which can be very dangerous. So each sort of concept seems to find its niche in popular culture. Some of it is more dangerous than others. But yeah, there's kind of there's no end to the amount of bullshit that's out there about quantum physics.
What has been the response that you have received from maybe some of these vulnerable groups or individuals? Have you received any response?
Yeah, I blog a little bit, and sometimes I blog about similar things. No one's responded directly to the content of the book yet. I mean, hasn't been out for only, it's been a couple of weeks, I guess. So yeah, nobody's sent me hate mail yet about the book, but I blog about kind of pseudoscience, misuses and misunderstandings of quantum physics, especially how it relates to concepts in psychology and philosophy. And there you get kind of standard long-winded, almost like book length replies, which most of the time you can't tell if it was written by a human or a robot. So a lot of it is just nonsense. It's nonsense. I get a lot of it just as a university professor, someone who's known as a quantum physicist. People send me their theories all the time, just wild stuff like gravity is equal to the speed of light. Some ridiculous thing. Someone looks at some formulas, tries to manipulate the formulas in wrong ways, and comes up with wild conclusions that are not even worth really responding to, unfortunately.
Well, we did some of that on the channel, so I think I'm very familiar with it. It's very difficult to understand, and it's very difficult to imagine that there's an actual person that's holding these thoughts and taking them seriously. Very good. Well, thank you for that. What about what's the connection between this kind of popular bullshit that's talked about in society and some of the controversies that circle in academic or in the academic arena? For example, all of the different interpretations of quantum mechanics. Do you see a link there, or is it completely different in your view?
Yeah, so quantum physics is interesting in that it seems to be the one science that has experts saying things that allow people to latch on and almost take those things as proof for their wild theories that are not considered at all. So something like the many worlds interpretation of quantum physics, which has sort of a mathematical foundation, but its popularization goes along the lines of, every time I make a choice, the various outcomes of that choice exist in parallel universes. So everything that can happen does happen, all existing in parallel universes. Okay, that's not true, right? That is absolutely 100% crap. But scientists say that. They say that in public. And then that, gets said as, this is proof of my wild theory, right? That I can help you jump into those parallel universes, take this 1-hour seminar at $1,000 a head, and I'll explain how to jump to parallel universes, one in which you're famous or one in which you're successful, and you can come back with inspiration from those parallel versions of you. And this is real science, because look, here's a Nobel laureate that said it, right? So there is a connection between the actual science of sort of, I would say, metaphysics or philosophy of physics, and popular science bullshit. And the distinction between them is sometimes very subtle.
Yeah, good points. Because some very prominent physicists, like you said, Nobel laureates in some cases, really truly push the many worlds interpretation. So it's interesting that prominent physicists and yourself, for example, would disagree on this kind of thing. So you say it's bullshit, but they say they say it isn't. So how do we know which one is right?
Well, the vast majority of scientists don't subscribe to this view, right? We subscribe to a much more boring view, which is quantum physics is a set of rules that allow me to perform experiments and make calculations and predictions extremely well. End of story. That's what it is, right? It's a tool for engineers, but that's boring. Nobody wants to hear that. And so people with those sorts of opinions don't talk about it in the media, or that maybe they do, but they don't get airtime. And they certainly don't get to go on the BBC and make, ridiculously over the top documentaries about it. So all the public hears is a handful of scientists all agreeing that the most comical and over the top interpretation of quantum physics is the one that they believe in, and the one that some of them say is certainly true, when it's a very, very small minority, right? It's just like climate. It's just like climate change, right? That it's the same thing. It's the exact same thing. So many worlds followers, especially sort of the pop science version of parallel branching universes, are like climate change deniers. There's one of them for every 1,000 scientists that concur that that's science fiction. That's just, comedy.
Interesting. You talk about this in the book, and the overall concept is the interpretations of quantum mechanics. In fact, this approach that you've talked about is one of those interpretations. Can you quickly summarize the different interpretations and why you land on or why the majority of physicists land on this particular interpretation or approach to physics? Although I think there's some people that disagree. I think, in fact, there's a physicist here in Spain who did a survey, and it was the number of people who believed in the many worlds or other interpretations was substantial. It was not minor, not like climate deniers, I think.
Well,
maybe I'm wrong.
So what happens is you get these groups of people who, verging on retirement, that get together at conferences and discuss interpretations of quantum physics, right? So already those physicists or philosophers are pale in comparison to the number of PhD physicists in the world, right? And there's an interesting bias towards going to these conferences and having more outlandish interpretations. Nobody's going to show up to a philosophy conference and say, "Oh, I'm an engineer," and I'm happy with that, right? So these polls that you see, there's been a few of them. One was by Max Tegmark, who's like the biggest proponent of the theory, who organized the conference. So, clearly all of his buddies are going to be there. It saddens me that things like that would even be published. I mean, that just shows almost that you have no understanding of how science works if you can't even evaluate the biases in the data you collect. It's not even worth mentioning. But people publish it and then it gets sort of cited and talked about because it is Max Tegmark or some other famous physicist. Yeah, so I wouldn't rely. I wouldn't even take that as data. It's worthless because we graduate thousands of PhDs in physics every year, and for the most part, not a single one of them walks away even thinking that an interpretation of quantum physics is needed. So by and large, the most popular interpretation of physics, of quantum physics, is that quantum physics needs no interpretation. That the people who think about it are wasting their time. They're like asking, how many sides does a circle have, or to them it's an illogical question, right? This question itself, there's a phrase in physics actually that fits, right? Not even wrong, right? Mm-hmm. It's not that it's so over the top that it's not even the wrong question, right? So, but within the people that think about interpretations of quantum physics, I would say that the most popular one is kind of known as the von Neumann Dirac interpretation. Sometimes people mischaracterize it as the Copenhagen interpretation, and that's ascribed to Niels Bohr. But the way the Copenhagen interpretation, or at least if you look at the Wikipedia article of it, is not really representative of Bohr's view on the topic. So it was more due to Dirac and von Neumann, who said that there's this object in the theory called the wave function, and that's how the universe behaves, except when we make a measurement, and then it turns into classical information that we can observe, and there's a different rule for that. So there's a distinct cut between the quantum world and the classical world that happens when a measurement is made. That's kind of the one that's in the textbooks, because the first textbook was written by Dirac, and then and von Neumann was the person behind the math, so a lot of the mathematical machinery of it, and many of the textbooks that followed took this approach because they quickly wanted to get students doing calculations. And then at the opposite extreme is, of course, the many worlds interpretation, which has its variants as well, but it's due to Hugh Everett, who came up with it, in the mid 20th century, and his was a bit tamer than the way it's currently interpreted now. He just said that you don't need this measurement thing to happen. There's just the wave function, and it evolves, and that's it. His story was that was it, and his thesis was about explaining why measurement kind of seems to be a thing that is observed in the world, even though on his view there's just a wave function that evolves continuously. And then there's lots of things in the middle. There's there's another one called the kind of quantum Bayesian interpretation, which is kind of a mix between Dirac and Bohr. So this object is not really a physical object, but it's subjective information of the person, the user of the theory. They call them agents. So the things in quantum theory are just the information that agents possess about their expectations for what will happen in experiments. And I think if you think hard about it, then this one seems to be the most plausible. And there's been some prominent physicists who initially didn't like that interpretation because they want physics to be about real things, right? They want to get at reality. So one famous physicist is David Neumann, who initially criticized it, but then came to defend it, and was one of the most ardent supporters of this kind of subjective interpretation of quantum physics.
Yeah, thank you for that. It's interesting that the distinction between the Christopher Ferrie that we're listening to now and the one that comes across in your books. There's a very big difference. No, interesting. There's some really valuable things that you're communicating here. Regarding these different approaches to understanding physics, I'd like to offer something, maybe a perspective, and ask for your opinion. So, what is the purpose of science or studying physics? What is the goal? Is there a goal? What should be the purpose?
Science is a particular way in which we compartmentalize the world so that it's easier to tell each other stories about our common existence. And it's not, it's not necessary. It's not sufficient. It's just a way in which we found particularly useful at this time to pick away at pieces of the world, patterns in the world, different phenomena that we find interesting and we want to tell each other about. And it's a sort of a systematic way of making that as clear and concise as possible. And to the extent in which you think that's important and valuable, then so far science is the best way to do that.
Okay, well, interesting. Feyman talks about this in his famous lectures about physics being a question of having different stories or pictures of nature and different even mathematical formalisms. And a good scientist has as many of these in his or her head as possible, because he or she never knows where the next breakthrough is going to come from, right? So speaking of this breakthroughs, that's why I asked about purpose. What is the purpose of science? So what we do at EISM, we're trying to contribute in our own very humble way to this whole topic, and trying to bring some clarity, at least from our perspective, in that we have differences of opinion about what the purpose of science might be, what the purpose of life might be, etc. But it seems that one thing we can definitely agree on is that what we don't want to happen is we don't want to go extinct. So at the moment, there's, the world is full of nuclear bombs. So it seems to us a reasonable position to take when other scientific things are equal. In other words, when there's possibility to interpret or to tell different stories about quantum physics or about science in general, and other scientific and empirical things being equal, it seems reasonable to say whatever interpretation or whatever picture can lead us to eliminate nuclear weapons as a symbolic way to represent all of the dangers that we're facing. That is a preferable interpretation or a picture than one that has absolutely nothing to say about it, such as the many worlds. Does this seem like a reasonable approach to take?
I think so, but the important, there's, I guess, in that approach, you might find that the right picture is one that is, in some sense, obviously false. So is it okay to push that forward as a correct story or model or whatever of science if it achieves some goal that you've set out? I think for me, I would always, once a goal has been identified, then I prefer to just wait, and I'll tell you after the goal has been achieved what was the right answer, right? So you say, The goal is to not go extinct. Well, then we're talking about evolution, right? And at the end of the day, when we move into the future, we look into the future and we ask, okay, what was it, science, or was it something else that got us here? Well, it doesn't matter in some sense what it was. I can tell you right away that it was the thing that worked well in the environment that it was placed in competition in, right? So it's hard to know from here what that will be. Science seems like a good tool, but I don't think there's any sort of driving purpose behind it. I think it's just the thing that has beaten out everything else in the evolutionary competition, and it may be beaten out by something else to survive into the next generation of ideas. But I don't think there's any purpose behind it. Though, of course, you can, as you suggested, you could just give it a purpose, and that's fine. And if we all agree on that, then certainly. I wouldn't say that if we agree that it's good to eliminate all nuclear weapons in the world, that means that a particular science is the right way to do it, right? I don't think it necessarily is going to be physics. That seems more like a political or psychological human psychology problem than it does a physics problem, which may involve, well, certainly not a hard science, right?
Borderline quantum bullshit, no?
Yeah. I think it's a really tough question. It's one of those questions where I think it's more important to be open to new ideas and revising your assumptions and your methods than it is to, definitively say, well, this is the way, and if you don't believe that, then you're on the other team, right?
Well, interesting. Can I ask you, the picture that I previously painted, you said that there's something obviously false about it. And I'm sorry, I don't understand what you mean. What is obviously false about?
Well, I just mean, like, look, I think you said whatever. If I have a goal in mind, eliminate all nuclear weapons, and then whatever it takes to achieve that goal is in some sense good, right? Or in the context of science or interpretations of physics or whatever, it must be the right one if it achieves the goal. But that's not necessarily true.
But no, that's true. That's obviously true. But it's preferable from a human psychological standpoint. It's preferable in the sense that we want to avoid dying, even if we achieve that goal through a false conception of science, simply because if we die, we won't have a chance to figure out anything about science or reality or truth. Whereas if we survive, we can eventually figure out that we were deceiving ourselves and it wasn't the case. I mean, it's obvious. To me, it seems self-evidently true that we prefer, you as a father and me as a father, we obviously want the best for our children. And if we were given a choice to have our families, suddenly die in a nuclear holocaust versus not die, I think the obvious choice is that we don't want ourselves and our families to die. So if we can paint, so the proposal is this: of all of the different pictures of quantum mechanics and science in general, even psychology, whatever approach gets us to that point seems preferable to me. And it just seems like common sense.
I mean, I don't disagree. But I think that there are interesting extremes. So I'm just trying to think about the extremes, right? What if what it took was, lying to everyone or locking everyone up, right? You achieved the goal, but at what cost? So I think for me, the most promising approach is education, right? And that way you don't have to lie to people. You don't have to take extreme measures. You just give people the tools that they need to evaluate decisions rationally. And if we could do that, then
sure, that makes sense.
I think the rest would work itself out. Hopefully.
No, I think, I agree with you there. I think obviously educate and tell people, but we're talking about two different pictures or stories or frameworks by which to analyze nature or reality. And they're both equally plausible. They both have mathematical rigor behind them. They're both experimentally confirmed, etc. It seems clear that if we have that choice, going back to Feyman, you have 6 different models or pictures of nature. Which one is going to lead us to human flourishing versus human extinction? It just seems common sense to pick the one that leads to human flourishing. And go ahead. I'm sorry.
But I think that an alternative approach is to teach people that there is no right picture. There's no right story. There's no one true way to look at the world, right? There are multiple ways, and some might be suited to a situation in one instance and another in a different instance, right? So it's better to not just force people or to suggest that people make a choice between these alternatives, but to say that you have all these tools available to you, and the point is not to choose between them once and for all. It's to keep them all in your toolbox and take the one out that you need when it's useful.
Sure, that makes sense. In some sense, we're talking about how physics and evolution has always worked, right? Because we are the product of billions of years of evolution, and in this process, different species have come and gone, and things die or continue to live according to these physical laws, right? So if we could come to an understanding of these physical laws where we clearly understood, if we go down this route, we're probably going to not exist. Whereas if we take a different route, according to this picture, according to these laws of nature, we're likely to live longer or to flourish. It seems that the one where we lead to flourishing is more desirable.
Yeah, I totally agree. I guess my point is that that it's not possible to evaluate those outcomes, right? Even if you knew the fundamental laws of nature, you can't use them to play back the whole entire history of the universe and then forward in time to see what will happen, right? It's far too complicated. And so you need a multitude of theories that abstract different things away, right? So it's no longer about the fundamental laws, right? It's about empirical and phenomenological laws, right? That make no reference to fundamental laws, that might even be inconsistent with other fundamental laws, right? Because you just can't do it. It's not possible to program a computer with the laws of the universe and then simulate what will happen in the future. It's far too complicated. Even if you had a quantum computer, right? The complexity of that simulation is as complex as the universe. So you'd essentially be using the universe to simulate itself, and then you're back at square one. So I think that, to me, there's just a gulf that's that you cannot actually close between what are the fundamental laws, what are the fundamental truths of the universe, and then human goals, right? Societal goals, goals and purposes for civilizations and societies. There, you cannot connect those two things.
Interesting. Well, we come to an interesting juncture here between people disagreeing. No, people always disagree. Scientists disagree. Everybody disagrees politically on the left, on the right. We disagree, and this disagreement is studied in various academic fields. One of them being social choice theory, where voting is studied, and political theory, of course. And we recently talked to Michael Freedman, who's a Fields medalist and the founding director of the quantum computing at Microsoft. And of course, he's written a recent paper with a colleague of his at Microsoft, Glenn Weil, an economist, on social choice theory, positing a connection between the Born rule and quantum mechanics and political theory. And so it's quite interesting. So what you're saying that cannot be done, they're saying that can be done. But independent of the merits of those arguments, I think if we abstract away and see, okay, we're talking about two different pictures, and we're talking about physics, even if it's at different scales, because how a society decides to govern or to make its laws will determine how that society evolves. It's physical in nature. So there has to be a connection. No, there must be, even if we can't understand it at this point, there is necessarily a connection between the two, right? And that's studied in political theory. And there's open questions in political theory that are mathematical, that are rigorous, that are studied. If what Michael Freedman proposes and Glenn Weil proposed, if this different picture of quantum mechanics actually solves those open questions in social science, then it seems like a very interesting angle to at least be open to or experiment with. That seems reasonable to me.
Yeah, I mean, look, if you come up with a mathematical system that works well for a model, a toy model of reality, of societies or some phenomenon that you observe in the world, and it works, then by all means go with it. But just because it's the same mathematics that was used in a different field doesn't mean there's a connection between those two, right?
Oh, absolutely.
So
no, absolutely. It's
so
about experiment.
yeah, I mean, if you can make analogies. Deepak Chopra makes analogies between Hinduism or whatever sort of spirituality thing he's into lately, and quantum physics. That doesn't mean there's a connection, right? There's just because the same words are used, or just because the same mathematics and mathematical objects are used, doesn't mean there's a connection. So I'm all for it. I mean, that's a part of my research, right? I borrow ideas and concepts from machine learning and statistics and apply them to quantum mechanics, right? So this cross-pollination and cross-disciplinary research is incredibly important, but we don't want to delude ourselves into thinking more into analogies than what's useful, right? So I'm not familiar with the work, but already I can say that if I had read it, it would be in the book, because there's absolutely no connection between fundamental particles and agents in an open market, right? Sure, I'm made of fundamental particles, but that's a totally different thing, right? And I guess the other thing that you mentioned, I certainly agree with, but I should I should say that not everyone does. So that's sort of the idea of physicalism, right? That you say that I am made of fundamental particles, and those obey some fundamental laws. So therefore, I must be behaving according to fundamental laws. I mean, that's very simple and plausible argument, but we should be wary of such simplicities, right? So it's certainly something that I like. It's a simple story for how to make sense of the world around us, but not everyone subscribes to that, right? Not everyone is a reductionist in that way. But even if you are, right, even if you are, that doesn't mean that it's possible to describe in any sensible way, emergent phenomenon starting from the fundamental rules, right? They're just not in there, right? All the things that we said in this conversation, right? You can look at all you want at the rules of quantum physics, and you're not going to find them in there, and you're not going to derive them, right? Even if you believe that it must be the case that those rules give rise to me talking, you'll never derive them. It's just not possible. So that I think there are fundamental limits, even if you take this reductionist view.
Yeah, interesting. Well, I will say that I'm very refreshed by your take on Deepak Chopra and some of the bullshit that he peddles. It just seems like such bullshit. On the other hand, I think we could go on for quite a while about this. I think they're very interesting topics. I think ultimately it's about political theory and voting, because all of these different perspectives, you have one perspective, many different Nobel Prize winners have different perspectives. And how do we reconcile this on a human level without going down to fundamental physics? It's political theory and voting theory, and there's open questions in these academic disciplines. And if these open questions can be resolved by adopting principles and mathematical models from other areas of research, then I think it's a very interesting avenue to propose. Even if we're wrong, but if we can find a way to reconcile, the extreme right and extreme left in a way that everybody is not understanding, but it's just not going to lead us to destruction, I think is a promising approach. Allow me to you promised us an hour. You were nice enough to give us an hour, and we're approaching the hour now. Two last, one question and one request. The question is that, interestingly, another controversial topic, you write in your book that a person has volition or free will, and they should act on it. Can you comment very quickly on this? Because it seems this is also a very controversial subject. And I was struck by this concept that you invite the reader to act on their free will because of quantum mechanics, when many other prominent thinkers come to the opposite conclusion. They use quantum mechanics to say, no, you don't have a free will. It's just an illusion. So can you comment about this, please?
Sure. I mean, well, it's an hour in itself.
Yeah, I'm sorry.
So yeah, if you believe that there are deterministic rules that the universe follows and all the stuff in it, and either those could even be probabilistic rules like quantum physics, then there's no such thing as free will in most, I would say. Let me put it this way: your intuitive sense of free will, you have that, right? But if you think about it, if you try to think about it naively from a physics point of view, or in any sort of mechanical point of view, then that kind of free will doesn't exist, right? That is an illusion, and the illusion of free will is an illusion, right? So it's not that I could have made a different choice. Like if I played back time 5 seconds ago, I couldn't have said anything different than what I just said, right? So that suggests that kind of free will, right, is an illusion, because that when people think about it, they think about it that way, the mechanics of it. They think, oh, I could have made a different choice, right? And if that's not true, then I must not have free will. So that's usually, broadly speaking, how most scientists who talk about this in public phrase the problem, right? There's, a set of rules for the universe, and at any given time, the next instant precedes from the one before it, and you can't change that, right? But that's entirely consistent with me as an agent telling myself stories. So where my free will exists are in these hypothetical toy worlds that I imagine, right? I can project in my mind different scenarios into the future, right? Only one of them's going to come. Oh, actually, none of them are going to come about because none of them are real. They're all toy models, even myself in those models, right? And I can make decisions about what actions I'm going to take to realize those scenarios, right? And that's entirely consistent with a deterministic universe. And so you absolutely have that kind of free will, right? But I think the way, the thing that I was talking about before, the way to really appreciate that and internalize it and make use of it is to realize that, you don't possess truth. You can't know what this deterministic universe is going to bring about, right? You can caricature it and make toy universes in your mind, and using math and science seems to be a very good way of doing that and ending up with good decisions. And you absolutely have that kind of free will, and you should use it.
Yeah, fantastic. Well, you're right. This last question was at least an hour, maybe a couple hours or more. Very, very fascinating. That reminded me of another line of research that we talk about quite often on the channel, and that's Yakir Aharonov's two-state vector formalism, which has contributed, that picture has contributed concretely to quantum metrology and whatnot. So it's very, very fascinating. And it's very much aligned with what you just said, as far as I'm concerned. The idea that the future has an impact on the physical evolution of a system. In any case, going back to your book, I want to thank you for having written such an enjoyable book. Thank you for the time that you have given us today. And there was one line in the book where I just started cracking up, and I think it's a nice way to end it. You said, if there's one thing that I'd like you to take away from this book, can you finish the sentence? Do you remember what you said? Do you remember?
No, I don't know where that was in the book.
Yeah, you said, if there's one thing I'd like you to take away from this book, it's to recommend it to a friend. I was just cracking up. That was so good. That was so good. Well, I highly recommend the book to all the listeners. I will continue to recommend it to people who are new to quantum mechanics, quantum theory. So as a final note, what are the next steps for you in the book and for you in general? And where can listeners follow your work?
Yeah, I'm semi-active on Twitter. I have a blog on Medium. You can find those links on my website, csferrie.com. And yeah, I'll be doing more events. We're going to have a launch in Australia. If you have any Australian listeners, I have a local Australian whiskey distiller who's going to make a special release whiskey just to pair perfectly with the book. So we're going to have some fun with it. And in the book, I don't know if you read the back pages, but there's a little bit of a snippet of the next book that's coming out.
That's another hour. I hope you'll come back when your next book is out, because that's another hour. It's very interesting.
So
very fascinating.
Yeah, always writing more books, blogging, thinking, learning. Yeah.
Fantastic. Okay, well, thank you so much for your time today, Doctor.
Yeah, thanks for the questions.
To support our discussions with the world's leading thinkers, please see the video description or visit eism.eu/support. Thank you.